Hello everyone, my name is Rıza Keramadak. Together with my teammate Sercan Şıpka, we prepared this project called Statistical Analysis of Turkish Super League Football Players. In this presentation, we will examine player characteristics, market values, and scoring performance using statistical methods. The purpose of this study is to analyze football players in Turkish Trendyol Super League. Football is becoming increasingly data-driven, and statistical analysis plays an important role in scouting, performance evaluation, and transfer decisions. We focus on three main research questions. Do players in different positions have different heights? How is the market value distributed among players? And can age and score contribution help explain market value? For our study, we collected data from Transfermarkt. Our sample consists of 54 outfield players. To create a balanced dataset, we selected 18 defenders, 18 midfielders, and 18 forwards. We recorded 7 variables: player name, team, position, height, age, market value, and score contribution. This balanced structure allows fair comparisons between different tactical positions. Before creating our graphs, we calculated the class intervals for player heights. The shortest player in the sample is 172 centimeters and the tallest player is 201 centimeters. This gives us a range of 29 centimeters. Using Sturge's rule, we determined that 7 classes would be appropriate. The class width what was calculated was approximately 5 centimeters. Most players fall between 180 and 190 centimeters, which already suggests a fairly uniform physical profile. Cumulative frequency ogive. This graph shows the cumulative frequency of player heights. The curve rises quickly around the middle height groups and then becomes flatter. This means that many players are concentrated around the average height. The graph confirms that player heights are clustered near the center of the distribution. Frequency polygon. This frequency polygon provides another view of the same height distribution. The highest frequency occurs in 180 to 185 cm interval. The shape gradually decreases on both sides of the peak. This indicates that most players share similar height characteristics. Next, we calculate descriptive statistics. The average player height is 182.74 centimeters. The average age is 27.04 years. The coefficient of variation for height is only 3.38%. This shows that player heights are highly consistent. However, the coefficient of variation for market value is 178.36%. This indicates very large difference in player market values. A smaller number of added players account for a large portion of the league's total value. We then examined whether our variables follow a normal distribution using Shapiro-Wilk test. For height, the p-value is 0.0918. Since this value is greater than 0.05, we fail to reject the null hypothesis. Therefore, player heights can be considered approximately normally distributed. For market value, the p-value is below 0.001. This means market value is not normally distributed because a few players have extremely high values. With a sample size of 54 players, the central limit theorem still allows us to use parametric statistical methods. Thank you. Now I would like to pass the presentation to my teammate Sercan Şıpka.
Thank you, Kerem. This is Sergeant, and I will continue the rest of the presentation for you. First, we calculated 94% confidence intervals. For every height, the interval ranges from 181.06 to 184.42 centimeters. For average age, the interval ranges from 26.03 to 28.05 years. These intervals provide reasonable estimates for true population means. Next, we performed a Welch t-test to compare the market values of forwards and defenders. The p-value is 0.019. Since the value is smaller than 0.05, we reject the null hypothesis. This means forwards have significantly higher average market values than defenders. This result is consistent with modern football because attacking players generally receive higher transfer valuations. We also compared the height variations for defenders and forwards using an F-test. The p-value is 0.734. Since this value is greater than 0.05, we fail to reject the null hypothesis. This means there is no significant difference in height variability between these two positions. Next, we examine the relationship between age and score contribution using Pearson correlation. The correlation coefficient is negative but very small. The p-value is 0.047. Because this value is greater than 0.05, we conclude that there is no significant relationship between age and scoring performance. Age alone doesn't predict goals and assists. We then build a simple linear regression model. The purpose was to predict market value using score contribution. The regression equation shows a positive relationship. According to the model, each additional goal or assist increases predicted market value by approximately 725,000 euros. This indicates that offensive contribution has a positive impact on player value. The R-squared value is 0.92. This means score contribution explains about 19.2% of the variation in market value. Although this is significant, most of the variation is still explained by other factors. The distribution pilot doesn't show a strong pattern, which supports the validity of the regression model. Conclude that our study produced four main findings. First, player heights are extremely consistent and approximately normal distributed. Second, market values are very unequal and dominated by small number of elite players. Third, forwards have significantly higher market value than defenders. And finally, score contribution positively affects market value, although it explains only part of the variation. Thank you for listening us. We are ready for all of your questions.